Back. In this video, we'll be learning about magnitudes and directions, and in particular, how to calculate unit vectors. Alright, so unit vector form of a vector. So this should be a quick and short video for you. So the fact that what does unit vector means that a unit vector vectors can have long lengths, all right, and if we are not concerned with their magnitude and we are mainly concerned with their direction, in a lot of in linear algebra where you're concerned with vectors, in a lot of contexts, you're mainly concerned with whether two vectors are parallel to each other or what direction they're pointing at. We not if you're not concerned with what length the vector is, you just want to know whether this vector A or and this vector B are parallel or not. You don't care much about their length. You just concerned about the magnitude of direction, the ratio of the side. So you divide by the entire length of each vector so that you end up with like vectors that both in like have one length, you length of one. Okay, to make sure they have length of one unit, you divide the original vector. It has this A has some values for I. Let's say is 3i plus 5j. You do is you use Pythagoras theorem. You figure out what the magnitude of this vector is. This vertical lines indicate what the magnitude is. All right, so you say 3 square plus 5 square rooted. This indicates that I'm finding magnitude of A. How? Why? Because well, x and y are always perpendicular with each other. I and j are always perpendicular. Components of this vector are vectors, as they are perpendicular to each other. So you can apply Pythagoras to figure out the magnitude of the vector like so. So once you figured out what the magnitude is, in this case is 9 plus 25, which is, what's that? That is root 34. So you say, I'm going to just put this vector over root 34. So that means each component, 3 will be having divided by, have to be divided by root 34. So you put that in front of I and you put this 5 over root 34. So this makes sure that when I take this vector here, and if I want to find the magnitude of this vector now, I will get a 1. If you don't trust me, just do it for yourself. What is the magnitude of this vector now? If I take 3 over root 34 and square it, and add 5 over root 34. Sorry, that was a 34, not a 32. All right. And if I take that and square that, and then take the square root, I should get a 1. Now, I haven't written my working out in a logical fashion. I should have written that down here, but we calculated the magnitude first, then I went up and I put that there. So that's going to be, what's the answer here? It's going to be 9 over 34 under the square root. I'll have 9 over 34 plus 25 over 34. Wow. Okay, so you see what's 9 plus 25 is 34, isn't it? So there, that's why you're going to get 34 over 34. The square root of 1 is still 1. Okay, I did tell you, once you've divided by the magnitude of the vector, that makes sure that the length of the vector becomes 1. Alright, so let's wrap this up and I'll show you the example here was a vector 3i minus 6j. So I purposely used different values just to show you it works out with no matter what. So 3i minus j looks like that. Its magnitude is going to be 9. What's 9 plus 36? Is 45. So we need to divide each of the components by this number. The magnitude, we've rationalized, simplified as well. There's root 9, root 5, so that's why it can be written like so. So then we said we're going to divide each of those components by 3 root 5. Now 3 over 3 root 5, that cancels away the 3, and 6 over minus 6 over 3, that cancels away to minus 2. Alright, so the 3's kind of cancelled away. This is simplified version of the same vector. You could have written it like a column vector as well. Now let's test this out. What's the magnitude of this new vector? All right, this, let's call this, this is not v anymore. Let's say this is now like m. All right, so what's magnitude of m? It's going to be uh, 1 over root 5 squared, 1 over root 5 if I square that, and I add minus 2 over root 5 and square that. What do I get under the square root? I will have under the square root, I will have 1 over 1 over 5 basically, plus 4 over, that's a 5, not a 2. Alright, 4 over 5. What's 1 fifth plus 4 fifth is 5 fifth. The square root of 5 fifth is still, square root of 1 is 1, isn't it? So you see, it works out. When once you divide by the magnitude, everything. This is where you stop. This you could have stopped here. You don't have to test it for yourself. I'm just showing you that this is what happens when you divide each of the components by the magnitude of the vector. Alright, so I believe that's it for this video. When you have to solve some geometric problems here, you have to solve trigonometry and figure out the length of the triangle. You have to figure out the magnitude of vectors. That's why it's helpful. Alright, so good luck practicing. I'll see you in the next video.